Okay. How many people's brains melted over the break?
Woo!
So, one thing I do want to prompt you for. Sorry, I'm going to say something before we actually start. I said your exam was going to be on Friday, and it's not. It's not going to be on Friday. It's going to be next Tuesday, but that there's a conflict there because some people have a social diploma next Tuesday. Yeah. So what I'm saying is that for people who are writing the social diploma, you're probably not going to be writing the organic chemistry exam on Tuesday, so you'll write it on Wednesday.
What came problematic this Friday?
What?
What was problematic?
I wanted to give you some time to work on another project, and I wanted to give you as much in-class time to work on it as possible.
That's fair.
So I'm basically giving you Thursday, Friday to work on a project, and then on Monday we're going to review, and then Tuesday is going to be the unit exam. But we're going to be finished all the new information in the entirety of Chemistry 30 on Wednesday.
So for the people that missed it because of the diploma, do we write it in class the next
Yeah,
day?
you'll just write it in class on the next day if you want to. And if you don't want to write it in class because we're going to be reviewing some stuff on Wednesday, then that's fine. Then you can write it at like flex lunch.
Is that the major assignment due Monday?
Yeah, so the major assignment is due on Monday. Is that okay?
The diploma on Tuesday.
Is that for like
Every social class.
Well, next Tuesday.
Yeah.
It's like
Yeah.
the one where we have to write like 3 essays.
Okay, let's take a second.
I don't know if I can.
It's only like 2 things.
I think it's a good idea for us to just in case, on the off chance that not everybody knows when their diploma exams are, okay? Yeah, that's fine, yeah. Well, if you go onto the Thurber website, and you look at exam schedule, then there's an exam schedule there, it's totally fine, whatever. Today is not on the calendar because it's just too early, but next Tuesday, right? Today's the 6th, January 6th. So next Tuesday, January 14th at 9 o'clock in the morning is the Social Studies 30-1 and 30-2, just in case you didn't know that was happening. It is the Part A, right? So the Part A is totally written. Next Monday, if you didn't know, is the English Part A, right? So if you have English 30, next Monday is the English 30 diploma, okay? Next Tuesday is the Social 30 diploma, and I do not believe there's anybody in here that's writing FLA 30, but yeah. Shohei, you're ready to go, man. Next Thursday is English 10-20 Part A exams, but those are in class. Friday, English 10-20 Part A in class final exam. What?
What day does the exam break start?
The 20th, no, the 20th is a social studies part A. The 21st is a social studies part A. That's for 10 and 20. That's for the 10 and 20 subjects. So if you're taking social studies 20, right? There's lots of grade 11s in here, so there's probably lots of people who are writing that. That's the last day of classes. That 21st is the last day of classes. So you could either be writing the English or Social Studies Diploma Part A on Monday, Tuesday. If you're not, and you're in English 20 or Social 20, and then you're writing it either these 2 days or those 2 days, that's the last day of classes. Then it's Math Diploma, English Diploma, Social Diploma. And then on the following Monday, Biology Diploma, Chemistry Diploma, Physics Diploma, Science 30 Diploma. Right? So our diploma is January 28th at 9 o'clock in the morning in the BAM gym.
Make it noon.
Yeah, I super can't do that. So because it says all diploma exams must be written at the exact same time.
When do we come back?
What?
February.
You come back February 3rd, I think. Yeah, it is with these years. Yes, it is.
Do we have still on there?
What? No. I think that'll be a full Saturday or Sunday. Okay. So, do you remember? Let's go through what's going to be kind of on your quiz. The very first one, Chem 30 quiz. Recognize functional groups like alkyl halides, hydroxyls, carboxyls, and esters. Okay, we haven't talked really about carboxyls and esters. Do you remember what an alkyl halide and a hydroxyl group? No? That's fine, okay? Which of these compounds
Yeah, because there's the hydrogen.
does this make sense that that's a hydroxyl group?
Yes.
It's basically like a hydroxide that's attached to an organic compound, right? So we call this a hydroxyl.
Just that part or the entire thing?
Just that part is the hydroxyl, but the entire compound itself we call an alcohol. It's in a family of compounds that we call alcohols. Now, do you remember how to name this thing?
Start number plus your parent chain.
So your parent chain, and you start numbering closest to the hydroxyl group. So how many carbons in here? 2. So what's it going to end in? F-A.
No.
And we have to say where the all is. Yeah, F and dash 1 all.
I don't forget.
Otherwise known as ethanol, right? Yeah, we call this ethanol because it doesn't really matter if it's here or here, it just becomes the number 1. Yeah.
It's anything but location of like a hydrogen group or a carbon hydrogen group.
Yeah, the name where it is.
Do you write it in the word? Like,
Yeah, if it's a branch, right? Like for example, instead of this, if I said that, how many carbons are in our parent chain here? 1, 2, 3, 4, 5, 6. So this would be hex and 2 all, right? Because the all is on
3,4 dimethyl.
3,4-dimethyl hexane 2 all, right? So you would, at the beginning, you would say 3,4-dimethyl hexane 2 all. I did forget a dash. Thank you.
And like the double bonds and double bonds, they also go in like in the word.
Yeah, so it would be hex and
In
or hex 2 in 2 all. But you're never gonna get double bonds and an alcohol. You're never gonna get you maybe you might get like a chloro group on here or something like that, right? So the chloro group is still attached to 1, so this would just be
1 chloro.
yeah. 1 chloro hexane 2, right? But they would, if they're going to ask you a naming question, there's like maybe a 40% chance that you'll get a naming question. It really honestly is like a really low probability you're going to get a naming question. They're going to make it pretty simple. So they're going to have like a simple alcohol or a simple ene or a simple aromatic compound or something like that. Okay, so that's alcohols. That alcohol group does something to this compound. It's really interesting. It changes the properties of this compound. Do you remember what it changes about this compound? Yeah. What was that, Jordy? The solubility of it. Does this make it more or less soluble in water?
More or less.
Does the OH group, does that make it more like water or less like water?
More or less.
It makes this compound more like water, so it'll be more soluble in water, right? Does the alcohol make it more or less soluble in something called gasoline?
Well, is gasoline made of water?
No, gasoline is made out of, it's made out of, basically you can think of it as octane.
Okay.
Yeah, so it'll make it less soluble in octane or gasoline.
Water.
Yeah, please don't fill your gas tank with water, please. That actually reminds me. Sorry, I was at a family thing over the break, just like a lot of you were. And yeah, that's right. Yeah, I shaved at one point in time, I promise. And we were discussing the best places to fuel up with gasoline. Okay. And so I have a family member.
Tesla charging.
Yeah, sure, Tesla charging station. I have a family member who swears that it is not a good idea to fill up at places like 7-Eleven or places like convenience stores. And no, they said co-op's fine, but they said places like 7-Eleven or if like a Circle K had a gas station or something like that or whatever. And their reasoning was that they didn't think the quality of gasoline was as high as it was at, you know, Husky or Shell or something like that. But not for the reason, not for, you know, these people don't swear by like brand name gasolines or anything like that. Their problem was they were trying to prove it to me that these companies like 7-Eleven water down their gasoline.
Did you let that slide?
Does that make any sense to you at all? If you added water to vegetable oil, would they mix properly? Yeah, they are what we say is immiscible. They do not mix with each other, right? They form two separate layers. Would you be able to do the same thing with gasoline? Can water and gasoline mix with each other? No. So what are they going to water down their gasoline with, right?
Not water.
Not water. So it doesn't even make sense. Yeah. Now, ethanol obviously can be soluble in water, and ethanol is soluble in gasoline as well. And there are some places that offer up to like 10% ethanol inside the gasoline. Have you ever gassed up at a gas station before and it said ethanol enriched or ethanol added or something like that? Yeah, and so what they're trying to do is they're trying to make the gasoline a little bit cheaper and a little bit more environmentally friendly because we can make ethanol from food, basically, right?
Berries.
Yeah, we can make ethanol. Ethanol is a renewable resource. It's called biomass. But is gasoline itself renewable? No. So what they're trying to do is they're trying to make gasoline a little bit more renewable. That's the purpose of it, right? Okay, let's talk about alkyl halides. What do you have to have on an organic compound to make it an alkyl halide? You have to have one of the halogens. And so what are the halogens? What do we call an F group? Fluoro, right?
Fluoro.
Fluoro. Iodo. Good. And so we could take a compound and we could say that doesn't actually look like
It's like a.
So let's let's put another seal. Good.
Wow.
So just try and name this. It should be fairly straightforward, but if you're having some problems, let me know. Talk to your partner about it.
That is contained.
Go ahead and try and name it.
Okay, so that's
No, it's in one.
Okay, so
I know.
2
I got it. Name it off my head.
What's this gonna end with? Heptane, right? And what functional groups do we have on here? You have one iodo, and where is it attached to? 2. So this is going to be, we would call this a 2 iodo. And then what about the chloro? 3, 4 dash dichloro, right? So this is 3, 4 dash dichloro. Okay? Yeah, which one does go first?
alphabetical.
So does the iodo or does the dichloro? The chloro, right? It's because of the C and the I. We don't care about di, tri, tetra, whatever. So 3, 4 dichloro, 2 iodo heptane. Good. Okay, we're going to kind of review some reaction stuff tomorrow, if that's okay, but I feel like that was enough review. We're going to kind of jump into this carboxylic acids. Okay, if you weren't here on Friday, 3 Fridays ago, holy, we started talking about carboxylic acids. Carboxylic acids are organic compounds with a carboxyl functional group. So this is it's like hydroxyl, but the hydroxyl is attached to a carbon that's special. So this carboxyl group, we say it's COOH. Have you ever seen COOH before? Yeah. That's an acid group, and you've seen that tons of times. Those acids are soluble in water. Short chains are more soluble, long chains are less soluble in water. And we talked about why that was. Do you remember talking about octanoic and ethanoic acid? Right? This part can hydrogen bond with water, but the long hydrocarbon tail can't. It can't bond with water or hydrogen bond with water. So you've got a hydrophobic part. And what would be the opposite of hydrophobic? This is hydrophilic. So you can hopefully see how there's a little bit of a battle here. One part is very attracted to water, and one part is really not attracted to water. And so there's a battle here between the really hydrophilic part and the really hydrophobic part. Max?
Would it just split up then?
It wouldn't split up because the forces that are attracting and repelling, it's not so much repelling as so much it's just not as attractive as other things. Okay? So the difference in the forces of this molecule aren't strong enough to rip it apart. It's like if I was pulling on something and that something was chained to something else, do you think if it was big industrial chain, am I a strong enough individual to break that chain? No, I am very much not strong, right? Okay? So, but I still can, I can still exert a force on the rest of the molecule, right? So, okay. Naming carboxylic acids is really easy. You name it exactly the same way we normally name everything else, except the carboxylic acid is the start of our parent chain. We drop the E, so instead of propane with an E at the end, it would just be propanoic acid. We always end with oic acid. And it's 2 words now. This is the first time in our organic naming that we've seen 2 words in a name. So write the following names, the following compounds. We said methanoic acid, pentanoic acid. Let's do another example. Okay. So I would like you go ahead and name this using our rules, right? It's the same organic rules as we've been using all the time, except we change the end of the parent name. Instead of ane, it'll be anoic acid. That's it. What? So how many carbons in our parent chain? 5. So what is this going to end in? Oic. Pentan, right? But instead of pentane, it's pentanoic acid.
Does it matter if it's pentene,
It would. How many? Do you see any carbon-carbon double bonds or carbon-carbon triple bonds? Yeah. So if we totally could. I would have to change the number of hydrogens, but I could add a double bond here, and then it would be pent-2-enoic acid, or pent-2-enoic acid.
Because you start
Carbon 1, carbon 2, right? But we're not going to bother with that. I think that's a little too complicated for you guys right now. It's all good. Nope. I don't think you're ever going to see a double bond in carboxylic acid. Yeah, but if you do, you're prepared, sure. So where are the branches?
2, 3, darn. Oh, wait, do that first.
This is 1, 2, 3, 4, 5, right? So this will be 3, 4 dimethyl pentanoic acid. Is it easier to go from names to structures? If I gave you a name, could you give me a structure?
Yes.
Is it easier to go from a structure to a name? I personally think it's easier to go from a name to a structure because you always start at the end, right? Pentanoic acid. 5 carbons, and at the end of it is an acid group. And then you have methyl groups on 3 and 4. Okay, boom, no problem, right? So hopefully that's okay. Then we drew the structures. So we 3,4 dimethyl hexanoic acid. So that's what that was. And then we said benzoic acid. Problem. And so now we're getting, finally, it's 35 minutes into class or whatever, we're going to start talking a little bit more about esters. I want to be very clear, and I know this is going to go up on YouTube here in a second, okay? But so this is, but maybe I'll clip it. I don't know. We'll see.
Red flag.
So an ester is made up of two compounds that we've already talked about. An ester is made up of an alcohol and an acid. And when you react an alcohol and an acid together, it's called a dehydration reaction because you're pulling out water from this molecule and you get an ester. This is the ester functional group. What does the COO kind of remind you of?
That one formula.
The carboxylic acid, right? You can think of an ester functional group as being, it's almost like a carboxylic acid, but it's in the middle of a compound. So what happens here is that the alcohol and the carboxylic acid, if you were to just lasso this water and pull it out of there, you would get the CO, and the C is now bonded with the new O from the alcohol, and it just continues on.
Gotcha.
This is probably the most complicated reaction that we're going to talk about in the organic chemistry part of Chemistry 30, because people have a really tough time with this. People have a really tough time identifying carboxylic acids. Ester reactions, or if they have a tough time recognizing esters, ester reactions almost always need a catalyst such as sulfuric acid. Do you remember 3 Fridays ago doing the wintergreen reaction?
Oh, yeah.
And you had to do the reflux, you had to stick the big long tube on the top. And what you had to add drops of something before it could go. It was really extremely concentrated sulfuric acid. And so we needed that as a catalyst. What does the catalyst do?
Makes it work.
Speeds up a reaction
Makes the initial amount of energy lower.
by reducing the activation energy. That's all it does, right? A catalyst reduces the activation energy and speeds up the reaction. How would we write in a catalyst into this reaction?
Just put it up top.
On top of the arrow, we would say H2SO4, or you could say H+, because that's really what H2SO4 is, right? It's just a strong acid. Are we okay with that?
So why did you need to cut it?
What?
Why did you say you might need to cut it?
I'm gonna talk about that in a little bit.
Not to get controversial.
Nah, yeah, it is gonna get a little bit controversial. Okay,
Are we going to talk about evolution?
nope. Naming esters. Esters are named by combining the names of the alcohol and the acid that were used. Okay? So, if I had ethanol and if I had methanoic acid, I would name the ester that we make out of those things ethyl methanoate. It comes from ethanol and methanoic acid, so we call ethyl methanoate. So the naming of the ester is made from the alcohol first and the acid that's later. And the story that I'm totally going to throw Mr. Zukowski under the bus, he told me to say that, so it's not my fault if I get in trouble.
That's on YouTube now.
Let's say you're, I know, that's on YouTube. Let's say you're going to go out and you're partying, right?
Oh, we're getting controversial.
Not
We're
you,
getting controversial.
not you, but a hypothetical individual. Oh, Matt's 18 now?
18 today.
Ooh, happy birthday to you.
Happy birthday to you.
Happy birthday, dear Matt. Happy birthday to you. Good job. Matt, do you come to school tomorrow? Yeah. So anyways, let's say a hypothetical individual was going to go out partying, and you probably don't want to talk about yourself in this example. That's
Can you
fine. No, a hypothetical person. A hypothetical person is going to go out partying, and they're going to take. I don't even want to say. They're going to take 2 drugs. Okay? No.
What kinds? What kinds?
One drug is called alcohol.
Wow, that's
Alcohol is most definitely a drug. Okay? It has an impact on your body, and we can call it a drug. Now, no, the other one is
no sugar.
LSD.
alcohol.
Acid. Oh, what a mix. What a mix.
Okay, no. Shut up for a second, okay?
Trying to do an analysis.
A hypothetical person. No, shut up. If a hypothetical person was to go out partying, which one? No. Which one should they probably take first?
Alcohol.
Acid.
Take them at the same time.
Why don't you do it
Like, hey, it's a social experiment.
alcohol?
No. The joke is that you always take your alcohol before you take your acid.
See, I'm right.
Because the acid's going to hit you harder than the alcohol.
How do you
Now,
How do you know?
How do you
How do you know?
How do you know?
I don't. I've got no clue. I have no idea. That's why this is going up on YouTube, and I might lose my job over this. Okay? So you always.
Thank God it was hypothetical.
Yeah, thank God it was hypothetical. When naming esters, what do you always name first?
Acid.
You always name the alcohol before you name the acid. That's the reason why I said that story. That's the reason why I'm potentially losing my job. Okay? That hypothetical situation. So, I 100% regret saying that. Okay. Example, predict the products of the reaction between ethanol and propanoic acid in the presence of a catalyst. Now, let's take a look at this. Which one of these is the alcohol, and which one of these is the acid? Okay. So, the ethanol is the alcohol, and the propanoic acid is the acid. Which one, when we make our product is going to be an ester. It's an alcohol and an acid reacting together. It's going to be an ester. Now, which one should we name first? The alcohol. So the ethanol turns into ethyl, and the propanoic acid turns into propanoate. Can you see how the oic acid turns into OAte? They're related to each other. This is going to be the name of our product. That's the name of the ester we will produce. So let's draw this out. Let's draw an esterification reaction. We need to have the alcohol and we need to have the acid. So what does our alcohol look like? If I were to draw the structure of this alcohol, what would it look like? 2 carbons. It would look like 2 carbons with an alcohol group on one of them. The way I'm going to write it, the OH is going to face the acid, and the acid group is going to face the OH. That's the way I'm going to write this. So this is ethanol. We're going to react this with what? Propanoic acid.
That sounds like a really bad batch.
So what does propanoic acid look like? How many carbons? 3. And the way I'm gonna draw this, I'm gonna draw my acid facing the alcohol because they're the things that are reacting together. So I'm gonna draw the acid group facing the alcohol. So this is ethanol and this is propanoic acid, and what typically do we have to use as a catalyst? So we could put H plus, or we could put H2SO4. I'm sincerely happy with both of those. If you were to put either of those, I would be perfectly happy with that. So we need our catalyst. So what's gonna leave?
Water.
Water's gonna leave. Circle your H2O. You don't have to show that it's leaving, but I want to be very explicit about it. I want to show you that this water is leaving. So if this water leaves, let's follow the path of these carbons, right? The carbon's attached to another carbon. The carbon is no longer attached to an OH anymore. What's it attached to? An O, which is attached to the other carbons. So let's write this compound as if the water had left. So it's going to be a carbon attached to a carbon. That second carbon is now attached to an oxygen. What's that oxygen attached to? Three other carbons, right? Boom, boom, boom. What's attached to the first two carbons? Just hydrogens. So we'll fill it in with hydrogens. Remember, oxygen can only be bonded to two things, so it's already bonded to its two things. What's attached to this carbon here? It's a double bonded oxygen. And then we've got hydrogens attached to everything else. And what left? What left our reaction? Plus H2O. That is our fourth type of reaction. The esterification reaction is an acid and an alcohol reacting in the process or in the presence of an acid to make an ester and water. This group here
That right there.
that's what we call an ester functional group. And a key physical property for an ester functional groups is they often have very, very specific smells associated with them. Do you remember what was the purpose of making wintergreen?
To smell it.
Yeah, we wanted to smell some sort of like a minty something or other, right? Max, you had your hand up? All right, perfect, no problem. No, esters is the group, it's the family of compounds, and each one smells different. But they all smell like something. They all have a very characteristic smell. Yeah.
So, what's like, for example, like that makes it not freeze?
Ethanol.
Okay.
The freezing point of ethanol, I don't want. It's significantly under 0 degrees Celsius. I'm pretty sure it's somewhere around minus 40 or something like that. And so when you put ethanol, when you mix ethanol and water together, it's no longer going to freeze at 0 because there's ethanol in there, right? So it's going to freeze well below 0. So it's just the ethanol. That's all.
That's why you can't.
Okay. I would like you to try and figure out, name and draw all the products and all of the reactants in the following reactions. So do you want to do one together? Should we do one? Okay, let's do one together. What do you want to do first? Do you want to name these first two things, or do you want to draw the products? Okay, let's name them. So what is, this is an acid, right? It's not benzanoic. It's just benzoic. And that's it's a really weird kind of, it's just like an exception to the rule. We would call it benzenoic acid, but we just call it benzoic acid. And what is this alcohol? How many carbons are in that? It's not 4.
Wait, 1, 2, 3. Yeah, 3.
How many carbons are in this?
2 pentanol.
I'm an idiot that.
1, 2, 3. And so this carbon here, what's attached to it? An OH group. Is it fairly clear how there's only 3 carbons in here, but attached to that carbon is, yeah. Okay, so what would we name this? And then it's going to be propanol, but do we know where the all is attached to?
I do. 1.
Yeah, it's attached to 1. So propan 1-all. So what are we going to get? When this alcohol and this acid combine together, what are they going to make?
Whatever I put on my paper.
They're going to make water, right? So they're going to make water plus what? Yeah, we could draw it first, but you should be able to name this thing. An acid and an alcohol are going to make what? An ester.
Yeah.
And Kelton, what do we name first? The alcohol. We always name the alcohol before we name the acid. So this is going to be propyl. So we're going to make propyl. What?
Benzoic acid.
Benzoic acid turns into benzoate. Propyl benzoate. That's it. Now, when this thing reacts with this thing, what are we going to get? We're going to get water, sure, okay. But when the water leaves, circle the water in here. Where do you find, how can you get water out of this?
On the OH.
The OH and the H, right? Max.
Do you always take the hydrogen from the ethyl one? I mean, not the ethyl one. The
I always take the oxygen from the alcohol, but it doesn't really matter.
doesn't matter.
No, it's as long as you take the two H's and one of the O's, right? You're going to be left with one O either way. If you take those, water goes away. If you take those, water goes away, right? So it doesn't really matter. What are we gonna be left with? Let's draw the structure. We've got our benzene ring. And attached to the benzene ring is the carbon with the double bonded oxygen. But what's now attached to that carbon? What else is attached to that carbon now? Oxygen. The oxygen from the alcohol. So now we go O, and then we go up, up, up. Hopefully that makes sense. That we've got our benzoic acid is now attached to that propanol, and so it's propyl benzoate. Now it's really tough. This is the one class of compounds that's really, really difficult to go from the name to the structure. It's really, really difficult to do that. So what I would suggest for people that's a little bit easier is what substances would you need to make ethyl butanoate? Which one of these is the alcohol and which one of these is the ester? Or sorry, is the acid? So ethyl comes from ethanol, right? So let's write that down. We needed ethanol. And what else did we need to react with the ethanol? Butanoic acid. Butanoate comes from butanoic acid. Well, what does ethanol look like? We're going to use line diagrams. How many carbons in ethanol? 2. So, boom. And then what's attached to the 2 carbons to make it ethanol? An OH. So OH. And then butanoic acid. How many carbons in butanoic acid? There's 4 carbons in butanoic acid. So how do you draw 4 carbons again with a line? 1, 2, 3, 4. And that first one, right, is our acid. So let's circle water and get rid of it. You gotta go, you gotta go. Let's circle the water and get rid of it. And let's see what we're left with. How many carbons in a row here? 2. And what's that second carbon attached to now? The oxygen is the only thing that's left, right? So 2 attached to an oxygen. What's also attached to that oxygen? Yeah, a carbon attached to a double bonded oxygen. And then just 1, 2, 3, 4. 4 carbons. 1, 2, 3, 4. Now, let's take a look at this compound. And let's see, can we recognize how this is ethyl butanoate? How many carbons in a row before we run into an oxygen? 2, right? If I were to kind of like draw a line and separate this, can you see where the ethanol comes from? Can you see where the butanoic acid might have come from? Yeah. So that's why we name it ethyl butanoate. So we just always the alcohol before the acid. That's really fine. You gotta go, you gotta go. Okay. Esters. Esters are known for being sweet-smelling molecules. Now, I don't know about you, some of the molecules we made 2-3 Fridays ago did not smell sweet to me. They smelled like rum. Yeah.
Everybody made rum.
Yeah, they smelled like glue to me, every single one of them. Can I get you? Let's name these, please. Let's name these substances. So, can you see an ester group in every single one of these?
Yeah.
It's a COO in the middle of the compound. Every single one of these has a COO. That's different from an acid, which is a COOH at the end. This is a COO in the middle. So what I would suggest is, do you see where that's the carbon oxygen and then the oxygen is? I would kind of like just draw a dashed line in between them and see if you can name them based on that. Do you see how one side is an acid and one side is an alcohol? Try and name the alcohol first and then try and name the acid. So name these substances. Yep. And we're going to do lots more practice on esterification reactions tomorrow. We're going to do lots of reaction practice tomorrow as well. I just wanted to give you an overview.
I didn't write it yet.
How many carbons? Yeah.
That's the acid.
Because it's like a butyl group.
Yeah, you kind of think of it as a butyl group attached to the ester. Now the ester belongs more, doesn't belong to anybody because it's all one compound, but the ester comes from the acid. So we say oic acid turns into O8, and then there must be some sort of a branch on there. And the butyl is because of the group that butyl.
No one's looking at
Yeah.
Apple. Pears.
it. Oh, the last part.
Glue. Y'all want to sniff some glue?
No.
Yeah,
It's
alcohol's
not
virgin.
wrong first. That's acid. See? The acid. You can switch them around just with the
So how many carbons? And does this look like it's more of a
Okay, and it's the same thing as the other.
what is it?
I hate it.
Okay. And an acid to me looks like so when I look at this, if I cover up right hand side is this.
Yeah.
This.
No, I'm not gonna remember.
Do you not see that?
Does that make sense?
And
One side goes over here.
why?
Which side?
No, but I said that to you earlier.
But
You told me about it. Stop telling me.
I agree. If it was you're, so if you look at but what I'm saying is that you need
Can you stop? Turn around. I don't care.
Disrespect what I'm talking about. Come on, we don't need them.
No, the first one, not. Look. That has to be one.
Yeah.
Then when I asked Matt about that, he said yes.
Yeah. So this comes from
I'll just do this.
like if because does this look more like this looks more like an alcohol, right? Ester is part of the ester, but the ester comes from acid. So this used to be alcohol. This look at the acid bond. Made the alcohol first, and then read it like, oh, so how many carbons is the alcohol? And then how many carbons is and it comes from butanol and ethanol gas.
Alright.
Yeah.
Okay, well then come back here. Did I copy everything?
How does it measure?
It'd be butyl ethanol.
Yep. Yeah, from here, down here, you do 1, 2, 3, 4.
Yeah.
Okay. So I just want to do one, and then we can answer any questions that we need to, or something like that. Can you kind of see if we were to, if I was to like cover up parts of this here, filled with yellow. That's a gross color, but whatever. So when I cover up this half of the molecule, does that half of the molecule, does it look more like an alcohol or more like an acid? this with the C double bond O, it makes it look more like an acid, right? When I cover up the other half of the molecule, does that look more like an acid or an alcohol? That looks like more like an alcohol. So the way you name esters is you name them starting with the alcohol first. How many carbons in this? 4. So that's butyl. And then how many carbons on the other side? 2. So ethanoate. Oh. Butyl. I tried. It's Monday, January 6th. It'll be okay. Yeah. Does that make sense? We're just naming the alcohol first and we're naming the ester second. Or the acid second. That's all. So here, which side looks more like the alcohol? The left side or the right side? The left side. Well, how many carbons in the left side? 1, 2, 3. So that'll be propyl. And then how many carbons on the right side?
1.
Nope. 1, 2, right? So ethanoate. Is this kind of okay? Yeah? The third one, which one looks more like the alcohol? The left side or the right side? The left side. How many carbons in the left side? 2. So this will be ethyl. And how many carbons in the right side? 2, 4, 6. So hexanoate. And then the last one, the one that smells like glue, is going to be methyl ethanoate. Okay, methyl ethanoate. What 2 substances made methyl ethanoate?
Methanoic acid. I mean, no, that's methanol.
Methanol and ethanoic acid, right? Okay, all right. Doesn't seem that bad. Perfect. It's 11:43. I don't know. I don't want to say we're done.
I think 8's a good number to end on.
8's a good number to end on, so finish 8 and then end.
Oh, wait.
No.
I meant 8 is a good one to start with.
Oh, 8 is a good number to start with tomorrow.
Yeah.
Yeah, I agree. I'm totally fine with that. So, please remember on Wednesday, you're going to have a quiz. We're going to try and go over as much of that stuff tomorrow as we can.